All right, so this is your lesson 1.1. 1.1 covers expressions, order of operations, and like terms. So I want to start you off with your I can statement. Your I can statement is that peach colored sheet of paper that you picked up for your unit 1 as soon as you walked in. The unit 1 is called Equations and Inequalities, and our first lesson 1.1 says I can identify and interpret the parts of an expression and write an expression or an equation from word statements. So we are going to write down our I can statement. So I can identify and interpret the parts of an expression and I can write an expression / equation from word statements. All right, so this is a trifold. So the way that this journal actually works, I'm just going to kind of draw it off to the side. This is the beginning of it, the 1.1. You're going to fold right here. And you're also going to fold right here. So when you're done, you're going to have a little piece of paper that looks like this. This is 1.1. And then when you open it, your exercises here and here, and then this has a back page as well. Okay, so this is a trifold. All right, so let's talk about what an expression is. An expression is any combination of numbers and or variables that use addition, multiplication, subtraction, or division, or other operations such as exponents. Expressions are made up of terms. Expressions are made up of terms. I need you to write that there. And terms are separated by an addition or a subtraction symbol. Terms are separated by an addition or a subtraction symbol. We're going to focus more on terms, but our first couple of examples are about order of operations. Order of operations. So I'm hoping that you all remember your order of operations. I'm going to write it off to the side. P, you might have learned it as PEMDAS, right? Kind of write it like this. We know that the P represents parentheses. The E stands for exponents. Multiply or divide, and the reason I put them side by side, kind of try to throw a little arrow in between them, it's because you use multiplication and division in the order they appear. So if divide comes first, you do divide first. And then the same thing with add and subtract. Same thing in the order that they appear. So I always try to look at my expression, and when I think about simplifying it, I think about order of operations. Do I have parentheses? No. Do I have exponents? No. Do I have multiplication or division? Yes, I do. I have multiplication right here, and I have division right here. Since multiplication comes first, I need to do that first. -1/2 times 6. So I say to myself, well, what is half of 6? Half of 6 is 3, so this is negative 3. I'm going to bring down my 8. I have a plus sign right here. And now I have the division problem, 24 divided by 6. Well, 24 divided by 6 is 4. So now what are my next operations? Well, I have subtraction and then addition. So I have to do the subtraction first, right? It's in the order that they appear. So 8 minus 3 is 5 plus 4 equals 9. All right, we're going to do that same thing again. So I look at example B and I start with the P. Do I have any parentheses? No, but I do have an exponent and I need to take care of that first. And I also have division. Since the exponent is in the denominator and the division is in the numerator, I'm going to kind of do those at the same time, meaning I'm going to simplify them at the same time. Negative 16 divided by 2 is negative 8. So I have negative 8 plus 5 times 2 to the power of, let's see, 2 to the power of 3. That's the same thing as 2 times 2 times 2, which is 4 times 2, or 8. So that's what I have right now. Now I have to take care of this multiply. 5 times 2 is 10. So I have negative 8 plus 10 over 8. Well, negative 8 plus 10 is 2, and 2 over 8 simplifies to 1/4. These basic order of operations problems are actually non-calculator problems on a quiz or a test. So you should be able to do these basic operations without a calculator. Let's look at example C. I have an exponent and an exponent. I'm going to take care of those first. And I want to actually just talk about this one first. 5 squared, that's 5 times 5, which is 25. When I look at this, the 4 is being raised to the power of 2, not the negative. It is not a negative 4 being raised to the power of 2. If it was a negative 4 to the power of 2, it would look like this. And it doesn't. It doesn't have a parenthesis around that negative. So I'm just taking 4 squared. Let's see, 4 to the power of 2, or 4 squared, is 16. So 25 minus 16 plus 3. Over my denominator, I can go ahead and do the subtraction because that's the only operation in the denominator. 1 minus 5 is negative 4. So now let's see. All I have left is add or subtract. I have subtraction that comes first in the numerator. 25 minus 16 is 9 plus 3 all over negative 4. Well, 9 plus 3 is 12 all over negative 4. Well, that equals negative 3. Okay, let's look at our next example. So I don't know if you're familiar with this. You should have seen this symbol. This is a square root. This is a square root symbol. And here's how square roots are derived. I try to always remind you of this. I think a lot of times kids aren't taught this. So if I ask you for the square root of 16, the square root of 16, that just means, here's how I want you to think about this. That just means that I have an area of a square that is equal to 16. Well, how did that square get an area of 16? Well, it came from taking 4 times 4. So the square root of 16 equals 4. That's why it's called a square root. Think of root as how it's made. The sides, or the area of the square was made from the sides, the beginnings, the roots of 4 times 4. So let's take a look at this. So even though this is not in your PEMDAS, a square root is essentially the same thing as an exponent. The square root is the same thing as an exponent, so we have to take care of that first. So I have 22 minus the square root of, well, what's underneath the square root? 36 plus 64. Well, 36 plus 64 is 100 all over this exponent, 2 squared. That's the same thing as 2 times 2, which is 4. All right, so I have the square root of 100. So that means that I have this square. Remember that on a square, all sides are the same. So what do I multiply to get 100? It has to be the same thing, right? What number do I multiply by itself to get 100? Well, that's 10. So the square root of 100 is 10. So I essentially have 22 minus 10 all over 4. And 22 minus 10 is 12 divided by 4 equals 3. So that is exercise 1. So now I'm going to open my flap of my trifold, and I'm going to go to exercise 2. Exercise 2 is evaluating an expression. Evaluating an expression. So when we evaluate an expression, we just substitute in the number for the variable. That's all we're doing. So instead of using the variable n, I'm going to replace that with a number 12. So this becomes 25 minus 2/3 times 12. Well, I have a fraction times a whole number, so I'm going to turn the whole number 12 into a fraction because I think that it's going to be beneficial to remind you of how to multiply fractions. We multiply fractions straight across. So this is really 25 minus, let's see, 2 times 12 is 24, over 3 times 1 is 3. Well, what is 24 divided by 3? Well, 24 divided by 3 is 8. So I really have 25 minus 8, which equals 17. All right, let's go to our next example. So we're going to evaluate, meaning we're going to replace the letter C. Every time we see a C, we're going to put -4 in there. That's what that means. So I have -4, the quantity is squared, minus 11 times C, which is -4, all over 3 times C, which is -4. All right, -4 times -4 is +16, and -11 times -4 is +44. Over 3 times -4 is -12. Let's see, 16 plus 44 is 60. So I have 60 over -12. And 60 divided by -12 is -5. Okay, let's look at example C. Again, we're evaluating, meaning every time we see the letter T, we're going to replace it with the number 6. So 1/2 times T squared, well, that's 6 squared, minus 2 times T, well, that's 2 times 6, plus 9. I have to take care of exponents first. Remember, order of operations says you do exponents before you multiply. So I have 1/2 of, well, 6 squared, 6 times 6 is 36. Minus, let's see, 2 times 6 is 12, plus 9. I still have a multiplication that I need to finish. So 1/2 of 36 is 18, minus 12, plus 9. Order of operations says I do subtraction and addition in the order they appear. 18 minus 12 is 6, plus 9 is 15. Okay. Oops, we have another square root. So this means that instead of using x, I'm going to replace the x with an 8. So I have the square root of 5x, which is 5 times 8, minus 4. Well, let's see. So the square root of, what is 5 times 8? 5 times 8 is 40. minus 4. Well, what is 40 minus 4? Well, that's 36, so I have the square root of 36. What number do you multiply by itself to get an area of 36 in your square? Well, that's 6. So the square root of 36 is 6. Okay. Now let's go to exercise number 3. Exercise number 3 talks about the distributive property. We should absolutely remember the distributive property. It just says that when you have a number outside of a parenthesis, you multiply each term inside of the parenthesis by that number. Whenever I distribute, I take the number on the outside and I multiply, and I do that by drawing arrows. I always draw arrows when I'm distributing. That helps my brain tell me that I need to multiply. Let's see. Well, x times x, that's just x to the second power. And x times 4, and that's a positive 4, well, that's just plus 4x. So that is what you get when you distribute. So it says express the following products as a binomial. That's one of your vocabulary words, and I want to talk to you about that. A binomial is just anything with 2 terms. Bi means 2. So this has 2 terms. Nomial is number, 2 numbers. 1 term, 2 terms. Remember I said at the beginning of our lesson that terms are separated by a plus or a minus. Okay, so this has 2 terms. Let's look at our next example, example B. Negative 4 times 5x and negative 4 times negative 8. Negative 4 times 5x is negative 20x, and negative 4 times negative 8 is a positive 32. Again, this has 2 terms. The first term is negative 20x. The second term is positive 32. I want to do one better and tell you that this number that is attached to the variable is called a coefficient. So my coefficient is negative 20, and this has 2 terms. All right, now let's use the distributive property and kind of work backwards. We're going to work backwards. We're going to kind of undistribute. So if you have a binomial divided by a number, it's the same thing as each term in your binomial being divided by that number. So here's what this means. I have a binomial divided by a term or a constant. It doesn't have to be a constant, though. It could be a variable. But anyway, that just means that I can rewrite this as each term in the binomial being divided by that number. And then I want to simplify. I want to simplify it. Well, 8 divided by 2 is 4. So that gives me 4x. Plus 4 divided by 2, well, that's just 2. So in this binomial, I have a coefficient of 4, and this has 2 terms. My terms are, I'll list them this time, 4x and 2. Those are my terms. Let's do this next example. So remember, I can rewrite this. So this is the same thing as negative 9x divided by 12 plus 18 divided by 12. This one doesn't simplify into integers. It's still going to give me fractions. Let's see, 9 and 12 are both divisible by 3. So I'm going to divide each one of these by 3. And 18 and 12 are both divisible by 6. So 3 goes into negative 9, negative 3 times. 3 goes into 12 4 times, and you can't forget about your x. Plus, let's see, 18 divided by 6 is 3, and 12 divided by 6 is 2. So again, my coefficient on this example, that's the number that's attached to the x, my coefficient is negative 3/4. It has 2 terms. We know that because we said it's a binomial. What are my 2 terms? Well, my first term is negative 3/4 x, and my second term is 3/2. All right, let's go on to exercise number 5. So exercise number 5 is about combining like terms. So let's talk about what a like term is. A like term is when you have an algebraic expression that has the same variables raised to the same power, same exponent. So for example, this term 7x squared, x is to the power of 2, y is to the power of 1, is a like term with negative 2x squared y. X is to the power of 2 and y is to the power of 1. But when I look at this example, I have 5x cubed, x is to the power of 3. It is not a like term with 10x squared. Why? Because x is to the power of 2. The powers on the exponents are not, the powers on the variables are not the same. So we're going to simplify each expression below by combining like terms. So I always try to use colors. So my first term is a 4x squared. So I'm going to look and see, do I have any more 4x or any more x squareds? And I do. I have the term negative 7x squared. So I'm going to write those two down. 4x squared and negative 7x squared. Now I'm going to go to my next term in my list. That's a positive 6y. Do I have any more y's to the first power? I sure do. I have a positive 3y. So positive 6y and positive 3y. Then I'm going to go to the next term that I have not done anything with, and that's that negative 5x. X is to the first power, and x is to the first power on that positive 4. So I have negative 5x plus 4x. All right, so now I'm going to simplify. 4x squared minus 7x squared. Well, 4 minus 7 is negative 3. So I have negative 3x squared. Plus, well, 6 plus 3 is 9. 9y. My last one, negative 5 plus 4 is negative 1x. So notice that I don't do anything with the variable term. The variable term is the same. It just goes along for the ride. I'm just adding the coefficients. So let's talk about this one, for example. How many terms does this have? Well, this expression has 3 terms. What are they? My first term is negative 3x squared. My second term is 9y. And my last term is negative x. I could put the 1 in front of that, but I'm not going to. What are my coefficients? Remember, coefficients are the numbers that are attached to the variables. My first coefficient is a negative 3. My second coefficient is a positive 9. And my last coefficient is a negative 1. Okay, let's go to example B. Again, we are combining like terms. So let's see, I have x to the first power, x to the first power. So I have 12 minus 8, and that gives me negative, sorry, that doesn't give me a negative, that gives me a positive 4x. I have a negative 7y and a positive 2y. Negative 7 and positive 2 give me a negative 5y. My last terms, a positive 3z and a negative z. 3 minus 1 is 2. So how many terms do I have? Well, this has 3 terms. Again, what are my terms? Well, my first term is 4x. My next term is negative 5y. And my last term is 2z. What are my coefficients? Well, my coefficients are 4, negative 5, and positive 2. Okay. Exercise 6. For each expression below, where x is the variable, combine the like terms and leave it in terms of the unknown. So basically, we're going to undistribute. This is kind of like factoring. I want you to think about when you look at this term, ax and this term 2x. I want you to think about, what do they both share? Well, they both share an x. That means you can take an x out. If you divide both of these by x, you end up with, I took an x out, I end up with a plus 2. Well, how do I know if I did that right? Well, you could always redistribute and see if you get the same thing you started with. X times a is ax. We always try to put our variables in ABC order. And 2 times x is a positive 2x. That is what I started with. They're exactly the same. So, again, the final answer of x times the quantity a plus 2 gives me what I'm looking for. I'm just trying to undistribute or factor. So you're looking for a factor, okay? So when I look at example B, what is something that each term has in common? Well, each term contains an x. So I can do the same thing. I can take an x out of each term. I'm going to divide each term by x. It's no different than dividing all even numbers by 2, right? It's the same concept. So when I take an x out, that gives me 7 minus b minus 2. Well, within this parenthesis, I have a positive 7 and a negative 2, and I can combine those two terms. That becomes x times 7 minus 2 is 5 minus b. Now, I know you're saying to yourself, whoa, wait a second. That is not at all if I distribute what I started with. X times 5, 5x, x times b, negative bx. And you're right, it is not what you started with. However, the expression that you started with was not simplified. We could have combined these two like terms. 7 minus 2 is 5. 5x minus bx. And now you see that you're right, okay? So again, you're looking for something that all of the terms share, and you're trying to divide it out or pull it out. That's called factoring, all right? Our last example or our last exercise for this lesson, exercise 7, is recognizing math words. Recognizing words that mean addition, subtraction, multiply, or divide. So we're going to try to underline these words. These should be very common words to you. So the word sum, that's an addition word. Twice a number, the word twice means that we're going to multiply by 2. Twice means multiply by 2. The word a, like the phrase a number, that just means you need a variable. So let's see, what are we doing? Well, we're going to add something together. It starts off with a sum. Well, what are we adding together? Well, we're adding together twice a number, 2 times some variable, and 5. Okay, that's what that looks like. Let's look at our next example. The difference of, well, the word difference means subtract. What are we subtracting? Well, we're subtracting a number. Remember that phrase just means any old variable and the number 12. So any old variable minus 12. Okay. In this example, it says a number x, so it tells you what variable you're using. The variable that you're using is x. Less than. This means subtraction, but it's a turnaround word. Here's how I want you to remember that. If you have 5 pieces of candy and I have 2 less than you, 2 less than you, 2 less than 5. Well, 2 less than 5 is 5 minus 2. So when you see that phrase less than, it's a turnaround word. So I have x is less than 6. That means 6x less than 6 is 6 minus x. It's not is less than the inequality. It's just the phrase less than minus. There's a difference. Quotient. Oh, that's a good one. Quotient means divide. What are we dividing? Well, we're dividing a variable. There's that phrase, a number. What variable are we using? G and 8. When we use, oh my goodness, I didn't mean to do that. When we use division, we don't use this symbol anymore, not in Math 1. We write everything as a fraction or a ratio, right? So really it's 9 divided by 8 or 9 over 8. So we don't want to use this. That's like elementary, middle school stuff. We want to write it like a fraction or a ratio. G over 8. G over 8. All right. The next one is the product of. Ooh, product. Hopefully you guys all know this as I'm saying it. Product means multiply. What are you multiplying? A number. Remember, a number is just any old variable. And 2. Well, that's the same thing as saying x times 2. We always put the number, when we're multiplying variables and constants, we always put the number first. It becomes the coefficient. So we rewrite it as 2x. And then that lets us eliminate that little dot there. We don't need that. That's just fluff. It's just extra stuff. We don't need it. Ooh, twice. Or we had twice at the very beginning. Twice means we're going to multiply by 2. What are we multiplying by 2? The quantity of. The phrase the quantity of says, hey, you better use a grouping symbol. You need to use a parenthesis. What are we putting in a parenthesis? A number, which is a variable. What variable are we using? Well, we're using the variable d. Less than, that means subtract, but it's a turnaround. 9. So in the parenthesis, d less than 9. That's 9 minus d. D less than 9. 9 minus d. What are we doing outside the parenthesis? We're multiplying it by 2. So 2 times the quantity of 9 minus d. This should have a 7 in front of it. This is a typo. 7 less than 1/4 of the number n. 7 less than, that's a turnaround word, subtract, turn it around. So that means the 7 is going to come last. That's what I mean when I say turnaround. You kind of switch the order. 1/4 of the number n. 1/4 of the number n. So it looks like 1/4 n minus 7. Okay. Our last example. If S represents Sally's age and her father is 4 years less than, that's a turnaround word, 4 years less than, so that means I'm going to subtract 4. 4 years less than what? 5 times Sally's age. Well, Sally's age is the letter S. 5 times Sally's age. So this expression is the age of Sally's father. Let's see. Let's check that. So if Sally was 10, that would be 5 times 10 minus 4. 5 times 10 is 50. Minus 4 is 46. Is 46 4 years less than 5 times her age? 5 times 10 minus 4? Yes. Okay. Alrighty. So this is your journal for lesson 1.1. So you've tri-folded that. You've glued into your journal your flesh-colored sheet that has your I can statements on it for Unit 1. And then this is your journal for Unit 1.1.